topic that I think is important but not covered often, and that's browser memory leak testing. So Rolf already introduced me. I won't spend any time here. I do love JavaScript. I'm very happy to work with it all day, every day at Append2 with some great people. And I want to ask you a question, and feel free to type in chat if you'd like. If I were to tell you that your app has a memory leak, what's the first word that comes to your mind? And by I could be your manager, I could be your customer, I could be your significant other. What if someone told you that you had a memory leak? How do you feel? Well, I've had these feelings in the past as well, and I'll share a couple of the ways that I've felt. Denial is one choice. Might say things like, well, maybe they just didn't wait long enough for it to be recovered. Maybe it's the extensions. They must have some extensions installed that's holding on to things. Maybe some sadness that we didn't catch it, sadness that we didn't understand why it was leaking, and ultimately scared. How do we figure this out? How do we move on? How do we take care of this leak? So my goal today is to discuss a little bit about the basics of browser memory management. Talk about some real-life situations that I've seen, both in client projects and in code that I've reviewed for others. Talk about some of the tools that you can use, things that you can really zero in on what that memory issue is. And finally, the idea is that hopefully after you leave here today, you can take a look at some of your projects and see if you have some of these situations going on. So just for today, what's our definition for a memory leak? This isn't something I copied from somewhere. This is just my definition for today. It's temporary memory allocation that the browser's holding on to longer than is necessary. So you've created some variables, you've created some objects, and it seems like everything is good. You seem like you're done with them, you don't need them anymore, but as your application goes on, you may find that it's actually causing problems as the longer that your browser's open. So in my opinion, why is this more common today than ever? Well, the rise of single-page applications. I think that most people are pretty familiar with how that has come about in the last few years. Some of that is due to some of the great frameworks that are out there, like Angular and Knockout and Backbone and Ember, and the list goes on. In single-page applications, typically your browser is staying on that same page for a long time. It's communicating with a backend via API calls. So by not navigating from page to page, you're not giving the browser a chance to really get rid of some of that memory that may have been hanging around but not causing problems. And part of that is these JavaScript heavy front ends. It's more common to be doing lots of things in JavaScript. We're doing things with audio and video and Canvas and SVG, and there's great libraries out there that help us do some really incredible things in the browser these days. And as part of doing that, there's so much code out there on GitHub and other sites, libraries, plugins, frameworks. One of the big places that I've seen leaks is really in trying to integrate all these things together. You have a problem, you find a plugin that seems great for the situation, you pull it in, but the way that you're using that plugin may not be quite how the author intended, or maybe the way that you're trying to combine things together can contribute to memory leaks. So a little bit about how memory is recovered in the browser. We'll talk about garbage collection. It's not just browsers. There's other environments where garbage collection is the way that memory is managed. And it's really automatic. So in general, you don't have to do something to say that, hey, I'm done with that memory. In garbage collection, when you don't have references to things any longer, when nothing can reference it, the browser is free to clean up that memory. So you don't have to do anything specific to make that happen. Now in older browsers, a technique called reference counting was used as recent as IE6 and IE7. And what this is it kept track of how many times an object was referenced. And when that went down to 0, then right away the browser could say, I can clean that up. Well, there were situations where that failed, especially in circular references. Just have an example there where we have an element and there's an object that points to that element, and then that element has an expandable property that points back to that view. And this is a pretty naive case, but it would cause that circular reference that would cause a problem because both that object and that element would have a single reference just to each other, even though nothing else might be able to reach them at that point. So modern browsers implement a technique called mark and sweep. And there's obviously a lot of complexity to how each browser actually implements it. But the idea is that periodically a garbage collection pass is made, and the mark part is that it goes from the root, so that might be your window object, it might be the DOM tree, the various things that are considered roots. It would go from there and find everything that it can reference, traversing through the different trees and leaves, and it would mark those objects, and then it would take a sweep through all of the memory allocated, and it would be able to remove anything that was left over. The diagram that I have here is from the Chrome DevTool documents, and I have a link to that here. It describes how to use some of these tools in Chrome at least. And it shows a root object here. It shows some references, so I'm able to traverse down into these references. And in this case, this 9 and 10 are no longer referenced. Maybe at 1.5 had a reference to 9, but at this point it doesn't. So it would be able to mark all of these, and then when it went through in the sweep pass, it would be able to say, well, 9 and 10 are no longer needed. Now, if 9 and 10 had that circular reference that we talked about in the previous slide, it wouldn't matter because nothing from the root can actually touch them. So it doesn't matter if they reference each other. They still would get cleaned up because there's no way to get to them from the root. So as far as tools go, in my opinion, Chrome has the most comprehensive tools available to look at memory leaks. IE11, however, though, has some really nice functionality going on in their memory profiling view. And we're going to look at both Chrome and then some screenshots of how IE11 looks as well. In Firefox, there's an about memory view that can give you a heap dump and let you do garbage collection from there, force it. There are some other extensions and scripts which I linked to here. If you come back through the presentation later on, you can take a look. Safari, it doesn't have a built-in tool to do it at this point, but they do suggest using the instruments tool, dev tool in Mac OS X. And here's how that looks. There's a template for leaks. You can actually attach it to the Safari browser or an iOS simulator or even an OS X application, and it can give you things like a heap dump, although it's much further away from the JavaScript, so it's a lot harder to interpret. So let's talk about Chrome a little bit. In Chrome, there are 3 different tools that you can use to investigate memory leaks, and I'll talk a little bit about why you would use each one. First, I'm going to show some screenshots and talk about it, then I'll actually jump into an example where we can look at each tool in action. The first is the timeline view, and there's a number of things that you can capture here, but one is memory. So I can check this memory option and I can hit record, and it'll let me over time see how the memory is growing in my application. And so the memory timeline is really designed, as far as from a memory leak perspective, it's designed to help you determine, do I really have a memory leak? The memory may be going up, but then eventually it may go back down. It just may take some time. So that memory timeline, it's not as much to dig in as far as what's that memory. It's more about, do I have a memory leak? This garbage can here, you can actually force a garbage collection, and after you're done recording, and again, I'm going to jump into the tool in a second here, I just want to talk over the screenshot. After you're done recording, you can actually look at a snippet of time here, and then you can dig into that a little bit and see, for example, the use JS heap during this time period is going up and up and up, which doesn't look good. The second tool is called the heap snapshot, and that will really be a dump of the entire heap at that time. Now, there is a lot of other stuff in there besides just the things that you have created. There's a lot of things that the browser uses, so it is somewhat challenging to navigate, so in some ways you want to have some clues as far as what to look for. You want to be able to search for some of your data. You want to be able to understand what applies to your application and what doesn't. The heap snapshot will let you do comparisons between 2 heap snapshots, so that's what we're showing in this particular screenshot. In this case, it's showing you that there's some new objects being created. You know, you could see if ones are being deleted, being removed. You can see the size of some of those objects. So the heap snapshot's really that nitty-gritty. You can really dig in and see everything that's currently in that heap memory. And then a newer tool in Chrome that's actually quite interesting is called Record Heap Allocations. And it's kind of like a combination between the memory timeline and the heap snapshot. So it lets you record over time, and it will be taking a series of snapshots as it goes. And the gray, I'll talk about the blue bar. So the blue bar, anytime memory is allocated, you'll see a blue bar indicating how much memory was allocated. When that particular memory is recovered, it will turn gray. So you can see all these gray bars in the past here. That's all memory that was allocated and then recovered. So this is a view that really lets you dig into things that happen over time in your application. Maybe you're going through a workflow where you perform some action, then you go back and then you perform that action again, and you would expect to be at a steady state of memory. The things that the objects you created while performing that workflow, you would expect them to be recovered. And this will help you understand when things are allocated and what's left. So again, I can actually zero in on a period of time here. So I'm going to jump into a quick example here, and I bumped up the font of the dev tools, so hopefully that'll come out clear. And I'm going to pop into a sample where really memory is being allocated again and again over time. And I can come in here and make sure memory is captured. If I want to, I can filter out some of the noise. In this case, I don't care so much about rendering and painting information. I can hit record, and we can start to watch it. It gives me some interesting information about timers being fired. In my case, what's happening is every second a timer is being fired and is adding some objects to an array on the page. So I can actually dig into one of these timers and understand exactly where that function is that's being called, which could be useful at times. But what I can see here is that memory is growing and growing and growing, and garbage collection, depending on the rate that you're actually creating objects, the garbage collection happens fairly often. So it's not like you're generally going to have to wait seconds and seconds for it to happen. It's happening quite often. So I'm going to stop recording here, and we can see the memory was going up over time. Again, I can dig into an area of time on there if I want to here. I can look at just a particular point in time, and I can do things like look at the number of DOM elements that are coming and going in the page, the number of documents, number of event listeners, and then the use.js heap in this case is what's most interesting to us. So it's going up and up and up and up. So that's a memory timeline, again, generally used to identify that, hey, I do have a memory leak. Let's look at heap snapshot now. So if you go over to the profiles tab of the dev tools, you can take a snapshot, and then once you have taken a snapshot, this button here will let you take an additional snapshot, and I'm going to do that so we can look at a comparison. So there's several different views. There's summary, comparison, and containment. There is an additional view called dominators that you can get to by checking a flag in the dev tools here. It's not particularly important for us to talk about today, but if you're looking for where that view is, you need to enable it in that dialog. So the summary tells us everything by what type of object it is, so the constructor of it. Things that are in parentheses are really system objects, and you'll see a lot of stuff here, float 32 array, things like that. A lot of it is things the browser has created, the browser is using. It's not stuff that you specifically decided to use. In this case, I'm going to filter it by my data, and I can see that there's 20 objects here. I can see the shallow size, that's just how much each of those objects takes. The retained size is that object and all of its references. So really, if it gets removed, then all of that memory would be recovered. So I can dig into my data and I can look at each one of these 20 objects and see why it's being retained. The distance here is that distance to that root. So remember that diagram? This would be the distance to that red, that initial root. And if I look a little bit in here, I can see that there's a window.currentData property, and that's why this my data is being hung on to. If I look at this one, I can see the distance now is 3. It's actually the previous property of current data. And if I look at this one, it's the previous property of the previous property of current data. So I think you can kind of see what my problem is here. If I jump down here, I'm probably going to see a whole bunch of previous. Yeah, so you can kind of get an idea why I'm having a memory leak. My object's keeping track of its previous data, and that's keeping track of its previous data. So this would be how you can use the heap snapshot. Now let's look at comparison a little bit. So in the comparison, I can choose between snapshots, so not just two. If I had many snapshots, I could compare over time. And I can see that there were 8 new objects, 8 new my data objects, none were deleted, and I can see some information about the size. And then the final one is containment. Containment is really those roots. Remember, we were talking about the root. The ones that you're going to want to concentrate is the window objects and the DOM trees. There is some other stuff that's really more specific to the browser, like the GC roots has other stuff in there that is not going to be as helpful to you. But if you dig into the window objects, you can see things like things that are hung on that window. So in this case, it'd be current data. You can see that jQuery is actually loaded, the my data constructor, and then all this other stuff is just Chrome, just features that are added on the window object. Another interesting thing to look at is DOM trees. So you can look at the current DOM trees, and then detached is really interesting because this is stuff that you removed from the page, but it's still hanging around. And in this case, we can see there's 3 detached elements. And I want to point this out because we're going to see it a bunch later. jQuery actually adds, when you load jQuery, it actually adds a couple of things, DOM elements that aren't attached, a fragment here and a div. These are, you don't need to worry about these. You'll see these if you're using jQuery. They're not growing, they're not changing, they're just there. So that is the heap snapshot, and we'll come back to that in some of the later examples. The last piece that I wanted to show is that record heap allocations. Again, this is fairly new, but it's pretty interesting. I can see, again, memory being allocated. It would turn gray if it was being recovered, but it's not. And I can see that over time. It's taking little snapshots over time. And when I stop recording, this is the fun part, is that I can actually dig into, a particular slice of time, and I can see exactly what was allocated during that time and what remains. If I were to look between, it would show me nothing here. When I get into some, you can see exactly what was allocated, and it's really not what was it's what's left. So if these were turning gray and I hovered over it, it's really nice because it would show you nothing. If this was recovered, you would see nothing, which is really nice. Okay, so that's a little bit about the 3 different tools that you can use, and we'll jump into those a little bit further when we get to the examples. I want to talk about Internet Explorer 11. This is that same page, a profile of that same page we were looking at, so we can see the memory going up. Again, when you're recording, you can take snapshots over time. One thing that's really nice in the dev tools, and just to point out, this is under this little camera thing. It's the memory view of the Internet Explorer 11 tools. One thing that's really interesting, and it's not as easy to see, but this is actually a screenshot of the page at that time. I found that to be really helpful to just get a bird's eye view of, hey, what was I doing at that time? Was I on the home page? Was I on the billing page? Where was I? So that's pretty nice. It tells you the amount of memory that was currently the page was using at that time, and then tells you a difference between the previous snapshot, difference in megabytes of memory, difference in objects, and then plus or minus. So that's a pretty nice view. When you jump into one of those snapshots, you can again navigate through the things that are out there by types. That'd be similar to summary in Chrome. Here I can see it by the roots, which would be like that containment view. One thing that I found really nice in Internet Explorer is that they have an option to turn off a lot of the stuff that the browser creates. So when I'm looking at this, I'm really just seeing the stuff that I've added to the page, which really helps to cut down on some of the noise. So Internet Explorer has kind of cleaned it up in some ways. I do think Chrome has more features across those 3 tools, but some of the little touches they have in IE11 are quite nice. And you can do a comparison again between the 2. So I'm comparing 2 snapshots here. I can see difference in size, that type of thing. Okay, so now we're going to jump into a few scenarios that I've encountered that have caused memory leaks. And um, generally what I've done is try to strip these down to the simplest form that you could possibly have. So I'm not going to include Angular and knockout and a lot of stuff in these scenarios that would just cause maybe some confusion. I want to just kind of narrow it down to a situation where you have some content on the page and then you're going to remove it. So in a single page application, a lot of time what you're doing is you're rendering some type of view, and then eventually the user wants to do something else. So you clear it and then you render something else. And that's a case now when I remove all those elements, that's a case a lot of times where there can be a memory leak. So the first one I'm going to look at is related to Bootstrap. So if you were around yesterday, you saw Bess's great talk on Bootstrap, and I'm sure that many of you have used it. And when using Bootstrap, one of the features we were using was the affix functionality, and that allows you to sort of have an element that's fixed on the page. And the way you do that is one of the ways you can do it is just to declaratively add some data dash attributes, and that will signal Bootstrap to say, hey, go ahead and affix this. And then I have a button on the page that I'm just going to remove this element. So again, I'm simulating that single page app where we're going to remove something, put in some different content. And I'm going to jump back over to the example here, bring up this affix. And so, as I'm scrolling, you can see this header stays in place. The examples are really bare bones. I'm not trying to really style them or something. But here, when I clear out that content, at this point, I would expect, hey, that table's gone, and we can move on and render a different view. So I'm going to take a heap snapshot here, and there's a few ways we could look at this, but I kind of like containment for this, and I'm going to jump into detached DOM nodes, and ouch. Now I see that 3, now this is that jQuery stuff. I said don't worry about that, so that's fine. But I look at this, I see 7,025 detached DOM nodes. Wow. And when I drill into that, sorting it by distance is quite helpful because generally what's hanging onto it is the thing that's closest to the root. And so I see there's a HTML table section element. If I hover over it, I can see some of the properties on that element. I can see it's got a fixed top on it, and I can see it's that T head. So indeed, it's the one that I put that data dash spy on. So when I look at this, one other thing about the color coding, so if you see an element that is coded in red, that means that it has no direct reference to it from JavaScript. If you see something in yellow, that's really where the reference is. So in this case, there's no direct reference to this HTML, this T head, but there is something holding on to it. So when I click on it, when I click on one of these elements, I jump down to this retainer section, and that's where I can really drill in and see what's holding on to it. I can see that it's a dollar element. It's represented inside of a dollar element variable on an affix object. I can see that it's being used as the context for some function. And in this case, it looks like a jQuery proxy function that really forces the value of this. And if I drill a little bit deeper, I can see, oh, there's some type of click event. And okay, there's a scroll and a click and a load event. Sounds like window events. And so at this point, I personally haven't attached any window events related to a fix. I just put that data spy and let Bootstrap do its thing. So when we dug into it a little bit more, inside the Bootstrap code, we found that it was adding some event handlers to the window. So the default target in this code happens to be the window. And I remember Dave mentioned this yesterday in his jQuery talk. This is what's called a namespace event. So scroll is the event, and the other stuff is just a namespace, which could help you actually remove it if you want to. So that's what we found in the Bootstrap code. And just a little reminder about how to remove events in jQuery. Let's say I'm adding an event, and the name of the event is event, and namespace is our namespace, and I'm adding some handler, some function I have. There's a couple ways I could remove an event in this way. If I just say window.auth event.namespace, it would remove all for this event plus namespace. So if I know that, hey, this is my thing, I put my namespace on it, I've got one instance of it, or every instance, it's okay with removing those events, that's great. You could just use that. If you do have access to the original function that was bound, you could just do window.off with the event and that handler. In our case with Bootstrap, we really don't have access to the functions that they use. In fact, they wrapped it in a proxy call, which means nobody has access to that function directly. And finally, if we don't include the event, if we just say .namespace, it would remove all events for that namespace. And so again, this was the code that we saw in Bootstrap, and we found that Bootstrap did not have a destroy method or a way for us to actually remove those events. So in our code, we were doing more data binding, so it didn't look exactly like this, but in our code, we actually do an off without the event name so that it got all of the events and remove them ourselves. Like I said, ideally Bootstrap would provide that functionality, but they didn't, so we had to take care of that. And this comes down to sometimes, like I said earlier, sometimes in these third-party libraries that you're using, the way you're using it is not necessarily the intention of the way it was created. So, so in this case, we had to go into the library and figure out what it was doing and figure out what we needed to remove. We found a similar thing when I was code reviewing a project with sticky table headers, similar functionality, but it was adding scroll resize events to the window, and that was hanging on to the entire table. In this case, the sticky tables headers had a destroy method that we could call. That's a pretty standard convention in jQuery plugins. Call that destroy method, and that took care of it for us. If you're pulling in third-party code, it's good to think about not just, hey, what does this thing do for me? What problem does it solve? But is this thing going to play nice in the environment that I have it? Does it have a destroy method or a way to dispose it? That's definitely something to consider when pulling in third-party code. So we called that destroy method. That took care of it. Scenario number 2, talk a little bit about global. So I won't spend too much time on it, but I think the guidance that everyone has received regarding JavaScript for forever now has been, be careful about creating global variables. As far as memory management, it's the closest thing to the root. It's not going to go away if it's a global variable or a reference by a global variable. It's not going to get cleaned up. So the code here is not too important. Let's say I have some view object that I'm creating an instance of, and I'm just doing this on a page or in a file that's referenced by a page. When I look here, this my view, it's going to end up on the window, and so is this app. So window.myview, window.app, those are going to be on the window. They're not going to get removed. So what can we do about that? Well, enter the iffy, immediately invoked function expression. There certainly are other ways to handle it too, but I'm sure that people have seen this in code, or you likely are using it. It's a way to create a scope where variables inside of this aren't going to be attached to the surrounding scope, which in our case would have been the window. And so what this is a function, and that function, we're going to call it right away. And if you want to put your paren outside, that's fine too. It's not important. Some people like it the other way. So in our case, one thing we could have done in that previous example, we could have wrapped our code here in that iffy. Now this my view and this app, they wouldn't be on that window, and they would go away as long as nothing's referencing it. You may be using jQuery ready block. One of the forms of that would be, dollar and passing a function in, and that would, it's inside of that function as well, so it still perform the same role that the iffy would. In the jQuery ready's case, it would just not execute that code until the DOM content has loaded. So in Blazon, I know that you're familiar with Blazon now if you've been watching the presentations, presentboldly.com. I encourage you to try it. It's a great tool. A while back, we found a bunch of DOM nodes were leaking in Blazon. And what it came down to was a tooltip library we were using called OpenTip. And we were data binding against OpenTip, say tooltip, next slide. There's a bunch of tooltips in Blazon, so any iconic button that you have on the screen, you can hover over it, see that great tooltip. And as we were navigating through slides, we found out that anything attached to these tooltips was just hanging around. And when we dug into it more, what we found is that it wasn't as complicated as it might seem. Really, OpenTip was globally keeping track of all of the tooltips. It had an array called OpenTip.tips, and every tooltip created was added to it, and there was no code to actually remove it. That wasn't part of OpenTip. Again, this comes back to the use case. OpenTip, it didn't realize it would be in this scenario of a single-page app where you're coming and going with these tooltips. So in our case, the code here is not super important, just that we had inside of our custom binding, we were creating a tooltip, and then later we actually added a disposal callback, and we had to remove the tooltip from OpenTip.tips, which is a global array that was keeping all the tooltips. Based on our binding, we also had to null out some references, but it's just a case where adding things to a global may be convenient, but it has other effects like hanging on to that memory. So, again, OpenTip probably should provide a way to remove that. Okay, moving on to scenario number 3, closures. Closures. Closures are, we've already seen it in some of the examples I've shown, but closures really are one of the major sources of memory leaks. And the thing about closures is this: we use them all the time. We use them every day. We don't hardly even think about them. We don't generally think, I'm creating a closure right now. We're just creating functions and we're going from there. The thing to remember is that from a memory standpoint, it really can create a reference, just like you were setting a property to some value. If a function is using a variable that's outside of its scope, that will be considered a reference. Just a brief example on closures here. I have this person constructor, and inside it I have a show message function, and it's alerting on this message variable and the name argument that gets passed in. And so I've created a new person called me, and I can now call me.showMessage. And so what's interesting about closures is that it's not just about what's in this function. It has access to this message variable. It has access to this name argument, and not copies of them. It's not a copy of message. It's not a copy of name. It can still access the actual variable. So if I had another method that changed the message variable, it would be reflected when that was called. So I won't spend too much more time on closures, but I do want to really recommend the Scopes and Closures book by Kyle Simpson. It's online for free, or you can buy it at Gitify if you've heard of him through his Twitter handle. It's part of his You Don't Know JavaScript series, and it really is, to me at this point, maybe the definitive reference on scopes and closures. I forgot my joke. I was going to say, I was going to talk more about closures, but it's out of scope for this presentation. Okay, let's talk about a specific scenario. Let's talk about a basic scenario here. So I'm going to come back and bring up, flip back to the code real quick. So I'm using jQuery here. We could be using raw DOM functions as well, but I know that everyone is pretty familiar with jQuery, so we're going to use it to ease some of the burden of cross-browser support. And one of the things you're told in jQuery, don't cache that selector. You're selecting some elements, don't do that again and again, cache it. So I created this variable $L. It's just an element by ID on the page. And now I'm creating a click handler. I'm updating the text when you click on it, and when you click the clear button, then I'm removing it. So I had to use $L a few times. Seemed like caching it was a good idea. But let's see what's happening here. So I open this up, and I'm going to clear that, so I'm removing it. I'm just taking a snapshot, and let's go into detached DOM nodes. Again, I see my jQuery stuff that I'm okay with, but here I have a div. If I hover over it, I can see, yep, that's my testing div. It's being held on to for some reason. And if I look down in here, I can see, well, it's the $L variable inside of some function. And what is this function? Well, it's that $L.remove from there. Okay, so if I flip back over, I can see, yeah, you know what? This event handler is still attached to that button, and now that $L is being hung on to. And since it points at that jQuery wrapper to the element, that element can't actually go away. So one tip here if I can actually name functions. So even in a function I'm creating anonymously here, I can give it a name. And that's really helpful in stack traces and in tools like this. So here's an example. I'm going to do this again, but I've named that function. And let's just take a look quick at that snapshot. I'm going to go into containment and detach DOM nodes and look at this div again. See, now it doesn't say anonymous function. Now it says my remove function. It's really helpful for trying to understand, what are these functions that are getting passed around that are holding on to these variables. In stack traces, it's really helpful as well. But in this type of scenario, it helps us get some clarity on what that function is. So we showed how you can name that function. Now, how would we clear up this memory leak? Well, the easiest way probably is that we could set $L to null. And so why does that work? Why are we doing that? Well, we're always going to have a reference to $L, but $L doesn't always have to have a reference to that element that's not getting removed. If I set it to null, this function still has reference to L, but $L, it's just not the element. Of course, we probably want to check that $L exists before calling remove if you clicked it multiple times. So that's an easy way to clear up that leak. But I want to talk about something now, the delete keyword. So we set it to null, but I'm sure you've heard there's a delete keyword. You've maybe used it in JavaScript. Should we have just deleted the variable? Wouldn't that kind of nuke it so $L didn't exist anymore? Well, the delete keyword is not intended to be used on variables. So if I create a message variable, I delete it, and then I log it out, it's still there. Delete keyword doesn't work on variables. It's not supposed to. Delete keyword can be used against properties. So I can do delete data.name, and then I can do type of data.name. It's undefined. So that's where it can be used, but you really want to be careful with it because it can cause some major issues with optimization. I would like to show that really quick here because I think that I found this really interesting. Let me flip over here. So let's say I have these myThing objects with a name and an ID, and let's say I have a function called clearName. And the thing about this clearName function, there's two different implementations of it. In one, I'm going to set it to null, and one, I'm going to delete it, delete the property. And I thought this was fairly interesting. So when I do this, I'm going to allocate 1,000 of those, and then I'm going to clear the name and take a heap snapshot. So actually, summary is good. I'm going to look at my thing here. I can see 1,000 of them. I can see that shell size, that retain size. If I dig in, I can see 20 bytes, 20 bytes. Not very much memory it's taking up. If I hover over one, I can see that it's ID 1. I can see the name is null. Now, if I do the delete, so if I actually delete that name property when I'm creating these objects, and now I do a snapshot, I thought this was fascinating. Look at the size now, 12,000 shell size, because I really deleted that property now. Look at the retain size, 424,000 bytes. Look at each one here, 12 and 424 instead of 20 and 20. So by deleting properties off an object, you really messed up some of V8's optimizations, and it could be the same in other browsers as well. So just a little bit about delete and how it can be a little bit dangerous as far as optimization goes. But the delete keyword, I don't want to say don't ever use it because there are some interesting uses for delete. Generally, you could use delete when you want to remove a property such that you can't iterate through the properties of an object and find it, or use hasOwnProperty to find it, or when you want to differentiate between a property existing versus having a value of undefined. So if I have an index object here with some ID as undefined, and I have index 2 as an empty object, if I just look at the type of each of them, it tells me undefined, and that's not very helpful. I can't tell the difference between whether some ID was even in there. Now I could do some ID in index, that would tell me is that property, can I iterate, if I was iterating through, would I find it? That's true. I might want to do hasOwnProperty instead because that would get just things on that object, not on its prototype. For example, toString I could find in if I was doing that on index, I would find toString. So my point is that if you do want to use delete, it still is okay to use it in situations like this. Perhaps you have a long-running index where things are coming and going, keys are coming and going, and you really don't want it to end up with thousands of keys where most of them are undefined. And when you iterate through them, you'd have to throw out the undefined ones. So delete in that case is still that's a very valid way to use it. Okay, a little bit about references and closures. So I made a change to the code that we were looking at before, and here's the change. I am not using $L down here anymore. I'm not using $L in my remove function. Remember, that was our problem. It was hanging on to $L. Well, if I don't use it, then we should be good, right? Well, it can be browser dependent, but in some cases, but in Chrome for sure, and in IE, all of the functions that are created within the scope seem to have some level of sharing of the variables that they're closed over. So even though I'm not using $L, it still is considered a reference of this function. And interestingly, in Chrome, if I were to comment out the click, or even just comment out that $L.text, now, even though I created that variable, it's not actually included. So in my opinion, I wouldn't kind of rely on these tricks. I would make sure that you're safe in all browsers. So how could we do that? Well, in this case, one thing we could do is move our block out of the IFI. If I move it down here, it has no chance to access $L, no chance to use it. Of course, we could just not use a variable there. If we don't need to cache it, maybe we could do it that way. One of the things that I do most often is try to create functions. Maybe it's not just hanging out here globally, but create a function to handle what I want to do, and then pass that function directly. So try to avoid anonymous functions when I can, and only include the things, the things that I need. So this would be another way to not include $L in that function. And finally, once we call that clear, we don't really need that event handler anymore. So what we could do is we could remove that event handler. So in the code down here, we could do an off or something like that, but in this case, I'm choosing to use one. So that's not a typo. I didn't mean to use on. One is a convenient way to do a one-time event handler. It'll call it when you click on it, and then it'll automatically remove it for you. So I found that to be kind of useful for sort of that one-time situation. Now this one has got me before several times. I don't even want to admit it, how many times this has actually got me. Be very careful if you're investigating memory leaks. Be careful about what you're doing in the console. If you're logging out elements or objects and they're sitting there in the console, they're not getting removed, even if they could be. So I've had cases where I'm investigating memory leaks and I am trying to do some logging to understand when things are getting created, when things are getting disposed, what element is that, where is that? Maybe I logged out the parent to see where this thing's getting rendered. If it's in that console, it actually won't get released, and you could start setting everything you can think of to null, and it still won't get removed. So just as part of investigation, be careful with that console. And the use of eval. Eval, I really don't think there's a lot of great uses for eval at this point. If you have a bunch of a JSON string, you're going to want to do JSON.parse. If you want to dynamically access a property, you should be using the syntax where you're accessing the property through braces. So eval is not something you should, if you are using eval, you may want to rethink why you're doing that. But the interesting thing here is that if I eval, even in this case, I'm just evaling an empty string that does nothing. But if the optimizer sees eval, it says, I may need all the variables that I could possibly access here. So $L actually gets included in this closure because it doesn't know, even though this is static text, maybe it should know. But yeah, eval is definitely a good way to go. I could see a legitimate use of eval, maybe some type of data binding or something you have in an element, where you actually got to take some text and turn it into some JavaScript object or code. But you definitely would want to isolate that as much as possible. Okay, scenario number 4, it's just going to be quick. timers and parent-child links. So that first sample we saw in the timeline, or we saw that memory growing and growing, this comes from a real sample from a code review. Two things to remember: if you're starting timers or intervals, the code here is not too important. I think this is a little more interesting. If you're starting a timer or an interval, and then it's possible that you're going to be removed before that timer comes up, be sure to keep track of the ID of the timer or the interval, and then call clear timeout or clear interval. So if you're creating some reusable thing and you're adding some timer, maybe you're watching resize, or you're doing an AJAX request, make sure you clear out those timers, because they're a major source of memory leaks as well. And then, this is nothing special, but remember we saw that previous. Be careful with parent-child links and cascading links to things like that. That burned the project in this case, but just make sure you're careful about how things are linking like that. Scenario number 5, this is the last of the scenarios. So now Doug yesterday talked a lot about messaging and subscriptions. One thing to note, and this is kind of similar to events that we've talked about already today, but in the observer pattern or in pub/sub, which I'll bring up as well here, when I'm doing something like item type.subscribe, passing my handler and my context, what happens is that item type, some other variable somewhere else, has a reference back to me. So I'm creating my object, yay, and then I'm subscribing to this item type thing. It has a reference back to me. If item type lives longer than I do, I can't go away as well because it links to me. Same with pub/sub. Amplify.subscribe, amplify, a library that append2 is written that can do some pub/sub amongst other things. And here I have a topic, and again passing my this and some handler. Amplify is definitely going to live a lot longer than my object that I'm creating. So in that case, if I don't unsubscribe, I can never be cleaned up until that subscription is removed. So let's say I had a basic view, and the requirement I had was, hey, when there's a session timeout, I need to set active to false. So I could subscribe to some session timeout topic and then set it to false. That's great. That solves our problem. We're decoupled. We have that subscription, and but again, Amplify is going to hold on to that reference to the view that I create forever unless I unsubscribe. So it's something to be mindful about. Now, a few lessons learned from some of the situations I've seen. Be very careful with integrating third-party code. We've talked about it a bunch today, but the way you're using it may not match the author's intention, and it certainly is fine to post issues and try to go back and forth and try to improve that library as well. But just be mindful, and when you're pulling in dependencies, don't just look at what it can do for you. Make sure it fits into the scenario you want to use it, and make sure you can clean it up. Be mindful of globals. I'm not going to say any more there. I think everyone's pretty aware of how that would work. And when you're creating reusable pieces of code, whether you call them modules, components, bindings, directives, whatever you're creating, think about life cycle. Don't just think about, I need to put this date picker on the page, I'm going to create a directive. Think about what it means to remove it from the page. Do I need to call destroy? What exactly do I need to do? If I created a timer or an interval, if I added a window event, make sure I can remove it. If I'm doing things like adding window events, don't use namespacing in jQuery, or keep track of your handler so you can directly remove that handler. It's all things that you should think about. Just like the functionality you're creating, think about it as far as how it's going to get destroyed as well. Logging and instrumentation are really useful. Sometimes you may want to stringify your objects, so it's not actually holding on to the actual object, just a string representation of it, or potentially build new objects with just the little pieces that you do want to log. You don't really want your logging to be the thing that causes the memory leak. Okay, quickly here, cleanup time. So I just want to point out a few libraries out there. I'm just going to ask the chat right now to tell me, as far as the projects, does anybody use things like Knockout, Angular, Ember, Backbone, React? Is anybody using any of those libraries today in their apps? I'm just going to quickly go through some of the way that you can do disposal in these. So knockout's the one I'm most familiar with if you're in custom bindings, and really my intention here is that you can come back and review these slides, so I'm just going to cover them really briefly. If you're inside a custom binding, you can add a dispose callback to the elements. When that element gets removed, you can run some cleanup code. If you happen to create a computed observable in a custom binding, you can add an option to say, remove this for me automatically, dispose of this automatically when the element's removed. If you're creating computed observables or subscriptions, you can manually dispose of them if you need to. And generally when you want to do that is when you're subscribing to something that lives outside of your object. Let's say I'm a view model and I happen to subscribe to something on the app. I may need to run dispose because again, that app has that link back to me, and I can't be cleaned up until that link is broken. Angular has some $destroy events, so like on any scope, you can subscribe to that $destroy and do things like cancel timers. Elements, it actually fires a $destroy event as well. So either the scope or the element, if you're in a directive, you could potentially be cleaning up something like a date picker. Ember, I know Ember the least here. I've done just a minor bit of work with it. But there are some component lifecycle hooks. Will clear render, will destroy element are the ones to look for. One is called when a view is re-rendered. One is called when it's actually going to be destroyed. So those are two hooks that you can use to do cleanup. In Backbone, a while back it would be more common to see things like this.model.on change and call your code. Again, this is exactly like those subscriptions. When you do this, this.model has a reference back to you. And so what you need to do is make sure that you're calling off. But in more recent versions of Backbone, 0.9.9 is when it was added. There's a new API called listen to, and it kind of flips it around. So instead of saying this.model.on, you can say this.listen to, pass in the model, the change, and the handler you want to run. Under the covers, it still does that subscription that was previously being done, but it's able to keep track of it, so it removes it automatically for you. And if you need to, you can use the stop listening API to force that as well. So in Backbone, be careful about the subscriptions you're making, and listen to will help with some of that automatically. The events that you add in Backbone views, those will automatically be removed as well. React is picking up a lot of steam right now. I expect to see a lot more out of React in future times here. Component will unmount. It's their lifecycle event that gets called. Here's where you can do cleanup for a React component. So as far as the future of memory leaks in modern web development, I think there's a bright future. Browsers are always improving, and frameworks and libraries are maturing, and a big reason for that is because the tools keep improving. And it's just it's a circular thing. As the tools improve, you're able to eliminate more and more leaks from these different libraries and frameworks. And also people are more aware of the type of things I talked about today. People are more aware of closures. People are more aware of removing event handlers, that type of thing. And new language features in ES6, there's something called weak map. It's basically a hash where the keys do not have to be strings. You can actually use a DOM element or an object as the key, but they don't hold on to that memory. So they won't prevent something from being cleaned up. And that's it. I'd be happy to stay around and chat, and I'll post a link to this presentation in there. But I hope that you can start taking a look at your applications, and fingers crossed that you don't have thousands of detached DOM elements. But yeah, definitely give it a shot. I'd love to answer some more questions if you have them. And thanks for having me at Modern Web Conf.
I think a bunch of us were saying that this is like really a 600 level talk. So this was amazing. I think a lot of minds were blown. I had one question that I was able to grab. I wanted to ask. Somebody was, I forgot who, and I apologize, I didn't capture that. Was wondering if, is there some memory leak difference using single quote versus double quote for strings?
No, not at all.
If any of you
Not to my knowledge, anyways.
I didn't think so either. I didn't see any other questions, or I didn't capture them. I might have missed them. If Loris has a question, so you would not recommend $.remove for huge element blocks?
Well, really, the issue is that so I had something inside that block that had that was held onto by something outside of it. So what it was a window event So when I added that window event, the window actually had a link back to something inside that block. So it's okay to remove it, but if everything is self-contained, if all the event handlers are inside that block, it'll get cleaned up automatically. But it's just the fact that we had something outside that we were subscribed to. It could be amplify, it could be a window event, it could be something outside that's pointing back to us. That's a lot of the cases where that problem comes in. The one other thing I just would say is that, you know, if some of those stack traces, some of the digging into that looks kind of complicated, I mean, it is a bit hard to interpret. I mean, I'm not saying I'm an expert in interpreting it. I think the best thing I can say is it takes some trial and error, and you just got to kind of get in the right area to say, oh, okay, it's a scroll event. Let me start looking into that. You don't have to really just dig into it and say, there's the leak. I'm going to just go fix it right now. It really just gives you kind of the ballpark of what I should start looking at. In some cases, it would take some trial and error. I don't think any of us wants to just start setting everything to null. You know, I don't want to add extra code setting every variable to null all the time. So it takes a little trial and error, but you know, just it gets you in the right ballpark.